Welcome to Mr. G Does Maths. One of my favourite problem questions here, I think it was an SMC question, so a Senior Math Challenge question. Although I will say this can be done with some GCSE level maths, albeit it's quite challenging. Either way, pause the video, have a good read of the question, give it a go, and I'll go through it for you in a couple of minutes. Okay, so how do we think about this sort of question? Because we seem to know very little. We know something to do with Sam and Joe. We don't have any variables. We don't have any. So the first place to start is probably just introduce a variable. And just because Sam begins with S, I'm going to call that an S, and then call Joe's age a J. So I've started to add some algebra to this problem. The difference between the squares of their ages is 4 times the sum of their ages. Take it slowly. The difference between the squares of their ages. So Sam's age squared is going to be S squared, and Joe's age squared is going to be J squared. So S squared minus J squared is equal to 4 times the sum of their ages, where the sum of their ages is going to be S plus J, and it's 4 times as large. So therefore, S squared minus J squared equals 4S plus J squared. Let's call that equation 1. Equation 2, so now look at the second line. The sum of their ages is 8 times the difference between their ages. Okay, so the sum of their ages is going to be S plus J. Now, the difference between their ages doesn't actually say which is older, and sometimes you have to be very careful with this in the question. However, here it doesn't matter. So I'm just going to let Sam be older. I'm going to say the difference is S minus J. I'm going to multiply that by 8, and that's going to give me my equation 2. So now I just need to do some maths with it. I've got 2 equations, 2 unknowns. This should fall out quite nicely. Again, a lot of this is just being very careful with how you're laying it out. So my equation 1 is going to turn into S squared minus J squared minus 4S minus 4J is equal to 0. That doesn't look a lot better, does it? My equation 2 is going to turn into S plus J equals 8S minus 8J. This is looking a bit more promising. Then what I can do is move all the S's to one side and all the J's to the other side. So let's move the S's over to the right and the J's over to the left. So add 8J to both sides, give me 9J. And take away S from both sides, it's going to be 7S. And therefore that means, and at this stage you're going to pick whichever one you prefer, frankly. We want the oldest child. We said Sam's the older child, so let's just get S in terms of J. So that means that J in terms of S. So that means that J equals 7/9 of S. I've got a second equation. Now at this stage, I'm going to move over slightly. I'll come back to the question in a minute, so let's try and remember what the question was at the end. I've got 2 things of note. So I've got a formula with a load of squares in it, which is up there, and I've got a formula which I can substitute in here. Again, if this is an exam, make it clear what you're doing. This wouldn't be an exam in the typical sense. So I'm going to take equation 3 and I'm going to put it into equation 1. So that's going to mean that S squared minus 7/9 of S all squared equals 4S plus 4J, which is going to be 7/9 of S. Doesn't look very neat, but I have an equation which is just in terms of S, and there is no J's there at all. So let's just expand this and frankly hope a little bit. So I've got S squared minus, well 7/9 squared is going to be 49 over 81. S squared. Well, I can simplify that. I'll come back to that in a second. And on the right, I've got 4 lots of S plus 4 times 7 is 28 plus 28 over 9S. So in both cases, I can kind of just collect the terms. So on the left-hand side, I can collect my S squareds, which is going to be 1 minus 49 over 81. And on the right-hand side, I can collect my S, which is going to be 4 plus 28 over 9. If, as I think this is an SMC question, that therefore means this should all be done non-calculator. So be very careful. So a few ways of doing this. Let's just tidy this up first. So 81 minus 49 is going to be 32. That's going to give me 32 over 81. And then I've got a S squared. Now, if we think about this bit here, the way I would solve this is I've got 4 plus 20 over 9, so I need to change these all into ninths. So 4 times 9 is going to be 36, plus 28 all over 9, which is going to be the same as 36 and 28 is going to be 64, all over 9. So actually what I'm going to do in one go is I'm going to multiply this by 9, that's s squared, and that's therefore going to be equal to 64s. Now, this is where you need to be a bit careful, a bit more A-level maths than not. At this stage I can say s doesn't equal 0, which means I can cancel an s down. So now I'm going to get 9 times 32 over 81 multiplied by s is equal to 64. Let's try and do some cancelling before we do lots of maths. So 81 and 9 is going to give me a 9 on the bottom. Should have left the 9 right there, 9. 32 divided by 9, well 32 and 64 cancel out to be 2, which therefore means that s equals 2 times 9, which is going to be 18. So, quick check of what the original question was, make sure we've answered the question. So, teenagers Sam and Joe, difference blah blah blah, what is the age of the older of the two? Well, I did stick with s, I worked out that s is 18, so therefore it is indeed 18. Doesn't tell me to do this, but of course I could work out that therefore J is going to be 7/9 of 18. 18 divided by 9 is 2 times 7 is going to be 14. Doesn't want that, only wants the older of the two. That's it, quite a nice question. I like that question. As I say, GCSE level maths, although it appears in the senior maths challenge, I believe. Usual thing, like and subscribe if you could please, that would considerably help the channel. Another one of these will be uploaded very